All right, so today we're gonna wrap up, or probably not gonna wrap up. We're probably gonna have to extend this to next week as well. But we're gonna begin the end of our Python learning for this program, which is the last thing we're talking about is functions and procedures. So the way I like to introduce functions and procedures is by introducing what a function is in math, or at least function notation in math. Some of you guys hopefully all of you guys are familiar with this already, what function notation in math is. We have the function name f of x. So f is the function name. That's how you could have multiple functions being introduced in a question. So f of x. You could also have g of x or h of x, or just like a whole bunch of different kinds of functions out there, s of x, or you could see s of t. The thing that's outside of the parentheses is the function name. The thing that is inside of the parentheses is your input. So the input is the variable name, whatever you are going to be using to plug in a specific value when it comes down to math. What is on the right-hand side right here is the output. So if you want to calculate a specific value, you plug it in, and then whatever value you evaluate to, that is the output. So if we go ahead and fill out this table, given our function f with the input of x, and we have this as our output, if we have a new input of -2, we simply plug it in into our function. So f of -2 f of -2 is equal to 3 times -2 plus 7. So we just plug in our new input, x is -2, and we calculate. This gives us -6 plus 7, which is 1. And if I have f of -1, this is 3 times -1 plus 7. This gives us -3 plus 7, which is 4. 4. And we just continue this pattern. If you want to plug in a value, you do just f of 0. That's 3 times 0 plus 7. 0 plus 7 is 7. And we normally have this notation because it can replace a different notation you guys might be familiar with, something like y is equal to 3x plus 7. If I wanted you to say what is y if x is 1, then I would literally have to say what is y if x is if x is 1. But with function notation, I could just straight up ask you what is f of 1. And then we could just do that calculation. 3 times 1 plus 7, that's 3 plus 7, which is 10. So function notation simplifies how solving these questions are introduced. Functions are also prevalent in computer science when you code. So if we take a look at an example, we could see an actual function in computer science. When we write a function in computer science, here we have a function name here as well. So this represents the name of the function. We also have inputs. So this right here, this inside of the parentheses, very similar to math, would be the input. And then we also have our output. Our output is this. These two functions are equivalent to each other. One is just written in a mathematical context. The other one is written in a computer science context. So let's dissect this a little bit more. When you want to define a function in computer science, or specifically in Python, you would define it a little bit differently in other programming languages, but in Python, you always define it by having this keyword first, def, for define. Then you have your function name. And then in your parentheses, you have your input, Or if you have multiple inputs, you could have multiple inputs. Then you have your colon. Then after an indentation, everything that is within your function, so all of the code that needs to be run in order for you to perform your function properly, will be within a code block. So kind of like when we had our if statement and our loops, we indented everything over so that everything that belongs in in that block itself would be associated through that indentation. Same thing here, but we're talking about for functions instead. But overall, same structure. We have our function. Everything associated with that function will be along the same indentation line. So here we have our code block. And once you're done running that function, if necessary, you could return the value. Or return the output, I guess. Maybe the output would be a better word. We will see plenty of examples today and also next week where we are going to be making our functions and seeing how to return these values and where exactly these are returned to. So let's just finish up this analogy where we connect a function in computer science and a function in math. Keep in mind the input or the function name, input, and output. So remember our function name is f. Our input is x, and we return this output right here. So when I call f of -2, we see that we have, we have the function name f. So we're going to look for the function that has the name f. Then we associate our input -2 right here. So instead of running this function with f or with our input x, our x is going to be a 2. So we're running the function where x is -2, and it should return 3 times x, which is currently -2, holds the value of -2 plus 7. So this is -6 plus 7, which is 1. We have x is equal to -1. Now, when we run this function, because we see that our x value, or sorry, our function name f matches up here. So our input is -1, so x is -1, and we are going to return 3 times -1 plus 7, which is -3 plus 7, which is 4. Then we are going to do the same thing for the next one, our function name f, and then 0. So x is equal to 0. We're going to return the value of, I ran out of room, so 3 times 0 plus 7, which is just 7. And then we will just continue this onward from there. We could have more complex examples, but before that, let's talk about some vocabulary that you're going to hear me throw around. We've already seen a function, a block of reusable code that is used to perform some task and possibly return a value, meaning you don't necessarily have to return a value. Now, there are some people who will give different definitions for function and procedure, actually, so just a heads up. But we're just going with the AP definitions. So the AP Computer Science Principles definitions. We'll go over these vocabulary words and I'll clarify that just a little bit more. So we did see a function before in the previous slide. Right here, our function was f with the input of x, and it had a return value. So that is a function that we had. But you could also not return a value, and that would still be considered a function. And maybe I should get rid of this word. That word might be a little bit confusing, but the AP Computer Science Principles test will use procedure and function quite interchangeably. So if you see procedure, you could think of that as a function. When you see the word function, you could think of that as a procedure. So these two are synonymous in the in AP Computer Science Principles. However, some people will say that a function you have to return a value, and then a procedure you won't return a value. That's also, you might hear that, but then remember, this is just strictly for the purposes of the AP test. Function and procedure are synonymous. So when you see procedure, think function. When you think function, you think procedure. Either of these words is just a block of reusable code that is used to perform some task and possibly return a value. So our task here is just to compute 3 times a number plus 7. That was our task. And notice that we were able to reuse this quite often. So we used f of -2. Every single time we call this function with a different input, we are reusing this code. And notice that you do not have to write 3 times -2 plus 7, 3 times -1 plus 7, 3 times 0 plus 7, 3 times 1 plus 7, 3 times 2 times 7. All you had to do is write f of -2, f of -1, f of 0, f of 1, f of 2. So this simplifies your code. It simplifies it, and that you don't have to write as much. And also, you can see that it makes it easier to read. Writing out this function and calling on the function in this way does not impede the way that you read the code. In fact, it would probably be more readable now that you've written it like this, because you have some kind of association. You're able to visualize the similarity in what you're doing in each line now. And the other word is parameter. So parameter and input are synonymous. Actually, I'm going to throw in another word here, argument. So parameter, input, and argument are all synonymous. So when we call -2, in this case, -2 is an input. You could also say -2 is an argument being passed. Here, this is the parameter. So it is the variable that is representing your input. So keep these words, which are also going to be on their AP test, in mind. Remember these words so that when you see them in the multiple choice test, you don't freeze up and forget. We'll be using this a lot, so I really don't think you'll forget. So let's talk a little bit more about return values. What are return values? When do you use return values and when do you not use return values? So you can see here, I have two pretty seemingly identical functions. If you look at both of the functions, we see that the name is identical. You can also see that the input is identical. You would never use both of these in the same program. The reason why I'm showing it to you guys side by side is for the sake of an example, but you would never use both of these in the same program because they're their signatures, so the function name and the inputs are the same. Don't do that ever. But let's go ahead and take a look at the right-hand function, the right-hand procedure, and see what it does. So a couple of observations, or actually one huge observation, you should be able to see that my function name has meaning to it. When you look at the function name, you could hopefully infer what the function is supposed to do. So make sure your function name is meaningful. So really, this right here, f, might not be the best function name because when you look at it, you can't really tell what it's supposed to do. But something like is even, you could hopefully tell. and understand what the function or the purpose of the function is without having to look inside of the code block. So just it's almost like naming variables. In fact, the naming variables and naming functions in Python have the same exact rules. So don't put in like weird numbers at the beginning, don't put in any special characters. The naming formats are going to be the same. And also remember that like naming variables, you want to make sure that the function name is meaningful. Going inside of the code now, everything here is indented. So that's another observation. Everything is indented. And also note that you could use further indentations to the right for any structures that you decide to implement inside of your function as well. But there should be nothing over to this side unless your function is complete. So everything that is indented to the far left is no longer part of your function. Let's go. Now we're gonna actually get into what is going on inside. So if num modulus 2 equals 0, we know that our input num, this is our input num. So whatever number is being passed into the function, that is going to take the place of our parameter num, and that is what we're going to use. So let's say num is 2. So if 2 modulus 2 is equal to 0, you return true. So this function just tells you if something is true, if the number is even or odd by returning true or false. If it's even, it returns true. If it's odd, it returns false. And here, we could see you return true, return false. So this returns a value. It'll return the value true, or it will return the value false. So when we return, notice in this right here, we returned a number. We returned -2. We returned 1, 4, 7. We returned values like numbers. Here you can return true or false. These are not integer values, they're not numerical values, but they're still Boolean values. You can return a Boolean value, you can return an integer value, a float value, a string, a list. You can return almost anything in Python. And I will say, different from other languages, you don't have to tell Python what kind of value that you are planning to return. So Python, for those of you who are taking or already have experience in other programming languages, you'll see that you don't have to define what data type is being returned. So you don't have to write int, or you don't have to write string or a Boolean for the data type of a function. You don't have to do any of that for Python. So for here, we have no return value on the right-hand side. So similar, we have the input num, and whatever input you decide to use for this function, or you decide to pass into this function, that will take the place of num. So num will hold the value that is being passed into the function. So if you decide to pass a value of 5 this time, or actually let's say 3, we'll use 3 just for simplicity. If you decide to pass 3 into this function, 3 modulus 2 is not equal to 0. That is false. So 3 modulus 2 is 1. That gives you a remainder of 1. So it would print odd. Notice that odd is not being returned. We are just printing it. No value will be sent back to the function, or sent back to the function call. Instead, it performs an action and nothing is being returned. So there is no word return. That means you know that there will be nothing that returns inside of this function. So that's a big hint. Typically, if there's no return in it, then you shouldn't expect the return value. But that's so if there's no return value, or if there's no return, there's no return value. However, if I were to say the opposite, there's no return value if there is no return, that's somewhat false. It's possible that even if you have return in your function, it might not return a value depending on how it is written. We won't encounter any of those examples today, but that definitely is a possibility. So let's actually go ahead and run this code. So this right here is separate. It's part of the same program as what we had here, but it is further on in our program. So let's say we have is even 4. So is even and then 4. That means 4 would be passed into our function because 4 is our input for our function. So if 4 modulus 2 is equal to 0, return true. So you return true, but unfortunately what's going to happen is true is returned into this position. If true is returned into the position, but there's nothing being done with it. Notice that there is no print statement. There is no if statement. There's nothing that can be done with the true. So you just return true and do nothing with it. It gets thrown out. However, let's say I try this line of code right here. Print 4. So first of all, if we have our terminal, let's say we have like our window, which prints everything for us, it would print the number 4. And then when it computes is even, which we just did before, but let's go ahead and do it again just in case. So we have is even 4. That means 4 is our input. So if num, so remember num is holding the value of 4, modulus 2 is equal 0, we return true. So we plug in true here. The value, the return value true, takes the place of where the function is called. So we print 4, and we should also print true. So this is what's actually going to show up, as opposed to here, where there's no print statement, nothing being done with the return value. So we just calculate it and then throw out the value. If we take a look at this right here, this line of code right here is even 5. Our input is 5, so is even 5. That num, our parameter, will take on the value of 5. If we go into the actual code block, if num modulus 2 is equal 0. So num is currently holding the value of 5. So 5 modulus 2 equal 0. We know that's false because 5 modulus 2, meaning 5 divided by 2, we get a remainder of 1, not a remainder of 0. So we are going to return false. So here, here, this will take on the value of false because what is returned is false. So it sends the value false back to the function call. And once again, we are at in terms of how this is written, we're at a position where we just get the value and we do nothing with it. So we just calculate it and then throw out the value. However, if we take a look at this part of the code right here, where we are printing actual values, we would first of all print out the number 5, and we see we have to print out is even 5. So we have to compute what would be returned first before we print it out. So same thing. We are going to call on the function is even with a input of 5. So if num modulus 2 is equal to 5, so this right here is 5 modulus 2 equals 0. If we divide 5 divided by 2, we get a remainder of 1, so we would return false. So right here, this would take on false because that is the value that is being returned to the function call. So we print 5 and false. If I were to run this code, however, this program, so we're not using this one right here. We returned a value for this function declaration of is even. But in the second one, so we're gonna run the same program over on this side, but instead of using our first function declaration or that definition, we're using the second one where it has no return values. If I go ahead and run is even for, it's going to replace or like pass the value for into our function. And 4 is going to be our num. So num modulus 2, or sorry, 4 modulus 2 equals 0. That is a true statement. So for this case right here, it will print even. So actually let me instead, oops, sorry. So let's say this is what is being printed. The first thing that would print is even because we could see is even for and that it prints. So this is the difference between having a return versus a print. So for return, we return the true value, but nothing actually prints. Nothing is being told to print. So oops, in terms of what is being printed here, we only had 4 true and 5 false. However, here, this one does print something. That's because our function is being told to print even. So it prints even. Nothing is returned, however. We'll see that in just a moment. We'll go on to the next function, which is even 5. So this time, 5 is being passed into the function. Here we have 5. So if 5 modulus 2 is equal to 0, so if 5 divided by 2, we get a remainder of 0, which we don't. That's a false statement, so we go here to print odd. So odd will print out this time. Once again, nothing is being returned, but the reason why things are showing up inside of our terminal or inside of our window where everything normally prints is because we have actual print statements in the function, and whenever those are being run, something will print. Let's move on to the next part of our program. Right over here. I'm gonna use that color. Let's do this. We're gonna do this part of the program now. Print 4 is even. So it will go here and then see that it has to print the number 4. So that's exactly what it's going to do. It's going to print out the number 4, and then it sees it has to print out is even 4. So before it prints out is even 4, it has to figure out what to compute for is even 4. So is even 4, we pass in the number 4. That is our input, and that replaces all occurrences of num. So 4 modulus 2 equals 0. It says to print even. This is a true statement, so it prints even. So it will print even, but nothing is returned. Notice that. Nothing is returned. Because nothing is returned, Python will default to returning none. That is what's going to happen in Python. So none is returned. This takes on the value of none. So on top of printing even, it will also print none. And then please note that these are actually on separate lines. The reason being because if you print even, this will be on a new line. So print even and then new line, and then it prints out whatever comes next, and that will be none. So there is a specific order to how this is being done. We are going to try this again with print 5. So we're doing this again right here. So we're going to try, when we go into this part of the program, we see print 5. So it's going to print out 5 first, then it has to print out is even 5. So is even 5 has to be computed before the actual value of is even 5 could be printed out. So we are going to run this function where the input is 5. If we run is even 5, if num modulus 2, so if 5 modulus 2 is equal to 0, which is false, we go here and we will print odd. So odd will print out. And then after that, we have to figure out the return value, but because after everything, nothing is being returned, the function will return none. So none will also be returned, which takes on, which will replace, or I guess take the place of the function. So we have to print out none as well, and that will be what our what everything that's being printed looks like. So when you design these functions, when you brainstorm how you want these to look like, when you think about, do you need return values and all of that, keep this in mind. If you decide not to have return values, you probably don't want to print out the function when in the function call. Comparing the two that we just did, you can see that when we did the return, when we had return values, it was necessary for you to print the value or print the function. And like, so when you call on the function, you have to print it, print the function. But when you omitted the print function, it wasn't very effective because nothing happened and nothing, or I mean, it didn't allow you to visualize what your output was. Here, you can see that this was sufficient. This right here was sufficient. No print statement was necessary because even though you didn't have a return value, you printed within the function. So there is no rule of thumb in terms of how you should think about the long-term goal, how you want to use these functions to better your program. Am I cutting out? Can you guys hear me okay? Okay, just making sure. I just got like a warning that my internet was unstable, so I just wanted to make sure. So think about how you try to brainstorm ahead when you guys try to do this. We aren't going to do anything too crazy because this is our first time talking about functions for today. So don't worry just yet. Now let's talk about inputs and parameters. So functions and procedures can have 0, 1, 2, 3, 4, 5, 6. You can have as many inputs and parameters as you need. But as long as the only thing that you have to make sure of is that the number of functions or the number of inputs that are in your function declaration has to match the number of inputs and parameters that you have when you actually call on the function. So if you take a look right here, we have our function print message. There's no inputs, so no parameters. But you can see here when we use it later on, there's no inputs being passed. This matches up, so that's perfectly fine. For the second example, you can see you have 1, 2 inputs, 2 parameters. And here, when you actually use it, you have 1, 2 inputs being passed. So this will work out perfectly fine as well. How much time do I have? Okay, let's go ahead and just run this, why not? So if we run print message, there's nothing being passed in, no parameters being passed in, but it's okay because it hopefully should work still. We're gonna go inside. So the function is called, so we have to trace back to where the function is, which is print message. And we can see message is equal to APCS principles. Now, for each character in the message, we are going to print out the character. So the first character is A, the second character is P, the second character, or the next character is a space, the next character is a C, the next character is an S, and then just so on. So this is what's going to happen when we run this program, or specifically when we get to this line of the program. And then it will just continue on after that. So you run your program, you get to the function, you go to the function, run the function, then you continue where you left off. Same thing here. You run your program, you get to somewhere that has a function, you're gonna go back to the function. Notice that you have an input wow, so this right here is going to be wow. And then you have another input 3, so you have your input 3 right here being passed in. For T in range times, so times is 3, and then wow is this string. Oh wow, that's not very visible. Wow would take place of this string right here. So for T in range times, which is 3, 3 is what we got by passing our input 3. We are going to, so T in range, that would be starting from 0, going up to and not including 3, so 0, 1, 2. That should be 3 times in total. We are going to print wow. So T is 0, so it prints out wow. And then T is 1, it prints out wow again. And then we have T is 2, and that prints out wow that last time. So this is what would print out here. This is what prints out here. Once we are done running this function, it will keep going from where it left off until the program is complete. But the takeaway from all of this, the number of inputs and the number of parameters that you have should match up, not only in, it should match up in the place that you declare the function and also where you call on the function. Okay, we still have some time, so I am going to do just more practice with you guys. I'm going to send a file in the chat. We're going to send 2 files in the chat, I guess. So I sent 2 files. You guys should be able to see it. Can everyone see it? You don't need to use it. All of that is right here as well. So if you just want to follow along, if you just want to download it for your reference and then just follow along, that's perfectly fine. This is what we're going to be doing. We're going to trace some code just to see how this program would work. There are a whole bunch of functions, so let's take a look at what it looks like. First off, if you look, you can see that this program, it might look a little bit different. I believe in the file that I sent, the difference is that this is all commented out right now. You might want to leave it like that as we go through. Oops. As we go through it, let's just go ahead and leave it all commented out. But as we go through, we're going to take a look at each function that you see. We have a total of 1, 2, 3, 4, 5, 6 functions. We're going to see this, actually, we're going to not use this anymore instead of function and procedure, because this is before I looked into the AP definition. But we're going to see how many inputs are there, if there are any inputs. What is the return value, if there is a return value, and what kind of comments or documentation notes would you like to add? So normally when I program, or like when I do code with you guys, I leave a whole bunch of comments. So I would like, or part of the AP exam is commenting. You have to include comments in your portfolio. So what kind of comments would you leave for yourself or for someone who's looking at your code? How would these comments better assist someone looking at your code, pretty much is kind of what you want to think about, or think of it as a way, let's say you step away from your program for like 2 weeks and you come back to it. You probably don't remember every little detail in your code. So what kind of notes can you leave for yourself so that when you look at it, you know instantly what your program or what your code block is supposed to achieve? Those are kinds of things that you should be thinking about as you go along. These, I think, overall will make you a better programmer. And talking about the comments specifically, it will make you a better programmer, and it will definitely make you more likable to a teacher or to someone grading your work. That being said, let's go into the first part of your code. So if you see the print high x times, in this case, it is on line 7, this one right here, you can go ahead and uncomment it. That way it can run. When we look for print high x times, that is the very top of the program, right over here. Print high x times is at the very top. And notice what is being passed. The number 7. Oops. The number 7 is being passed here. So we're going to pass the number 7. So x is equal to 7 here. And we are going to run this program for I in range x print high. This does mean that all of this right here is being skipped. None of this, I don't know if you guys can see this, all of this right here is being skipped. It's been, none of this actually runs unless the function is being called. Because all of this is commented out right now, none of that is going to be called except for this print high x times. All of this is ignored, so none of this is going to run. Only this is being run. So that means once this is being run, this will be called on. And because we're using number 7, we will be using the number 7 here, which also brings up something that I completely forgot to mention. There should be an order in terms of how you write out your code in general. So kind of like variables. When you wanted to use a variable, you wanted to declare it ahead of time. You don't want to do print y when there's no y being mentioned here. Similarly, you don't want to call a function and then declare it below. You want to make the function before you use the function. That's the reason why all of these functions are at the top right here, and all of these are below it. So also think about that kind of order when you are structuring your code. So now let's go back into running this function right here. We're going to print high x times. So print high x times takes in the value of 7. So this right here, this x value is going to take on the value of 7 because that is the x value that has been declared or that has been passed into the function. So for I in range 7, so if you have range 7, that means you start from 0 and then you go up to, but not including 7. So that means our range is 0, 1, 2, 3, 4, 5, 6. Not 7 because 7 is not being included. We are going to print high out in as part of our loop. So for I in range 7. So for I, when I is 0, when I is 1, when I is 2, when I is 3, when I is 4, when I is 5, and when I is 6, you are printing out high each time. So we should expect to see high to print out 1, 2, 3, 4, 5, 6, 7 times in total. And in fact, when you go ahead, so run the code with everything commented out except for the print high 7 times. And when you run this, a second. You should see, hold on, what's going on? There we go. We can see that high has been printed out 1, 2, 3, 4, 5, 6, 7 times in total. So I'm just using this over here on the right side, just because everything is in one place on my tablet. So it won't look exactly the same as yours, but the output should be the same. These ones down here below, they have not been run yet. Only the print high x times has been run. So it takes on a similar, it's almost as if I've commented out pretty much. But you can see the print high x times has printed out high like 7 times. If I change this input, so instead of 7, I change it to 3. What do you think is going to happen here? So what is the difference between having a 7 and having a 3 inside of the argument, or as an argument being passed to our function, print high x times? So you go ahead and run it. It will print out 3 times. So our x is equal to 3 is going to be, or x will be 3. So that means our range will be from 0, 1, and 2, not 3. So it just goes up to 0, 1, and 2, and it will print out 1, 2, 3 times in total because I would be 0, I would be 1, I would be 2. And each time it will print out high. So let's go ahead and answer these questions here. So first of all, how many inputs are there for this particular function? So the print high x times, how many inputs are here in particular? How many inputs? How many inputs? How many parameters? How many arguments? Very good. Only one input. So there's only one input, and that one input is X. What is the return value? Perfect. Nothing is being returned. There is no return value, nothing's being returned. We can see that because there is no keyword, there's no word that says return in there. All right, and finally, any comments that you guys would write in this? So there's no right answer to this, but to someone who's never programmed in Python before, how would you define this program? Like, what would you use to summarize this program? What would you say? Nothing? This is perfect? Yes, very good. That would be a perfect way to, just like a perfect comment you can write. So it prints, this function prints, hi, a specified number of times. Okay, so this is going to be cut off. It's okay. But we could just write it like this as a comment. I would say what you guys have right here, let's say just get rid of this. I think this is good, sufficient documentation for when you start to work on your portfolio for the AP Computer Science test. This is, you might want to add a bit more here and there, but I would say this is a good starting point when you, or something that you guys want to practice doing when you guys work on the AP project. That being said, let's go ahead and go to the second part right here, all the way down here. So if you are following along, go ahead and comment this out. So comment that line of code back out. Oops. And uncomment the next part right here. Find slope 7, 3, -5, -1. So let's say you run this, then 7, 3, -5, -1, everything is ordered exactly the same. So 7, if we take this would be your 7. Let's see, is there a brighter color? I don't know. 7, 3, -5, -1. These are going to be the values that take on each specific value. Or these are the values take on each specific variable, so each specific parameter. Because we're running out of time, let's go ahead and just like run this. So y2 is currently -1. So this would be -1 minus whatever y1 is, and this is currently 3, 2, which is -5 minus x1, which is currently 7. So if we compute this, this would give us -4 over -12, which is 1/3. Python will just convert the 1/3 into decimal. So this is going to be 0.3333, like repeating, 0.3 repeating. This is going to be what is returned. However, the way that it is being called, what is the issue here? What is the issue with the way that is being called? We know exactly what value it's going to return. But is that beneficial to us with the way that the function call is being called? Right, it's not being printed. So if you were to run this, nothing would print out because you would just run the program, but kind of like what we had before when we had in this situation. Here, you will compute the value. You'll compute the value here, but nothing is being printed. So it'll just get the value and then toss the value. So instead of just doing find slope, go ahead and change it so that it prints find slope. And that way you could actually see what is being run. So I'm going to change it on here. We're going to go ahead and print find slope instead of just calling on find slope. And you just see that it prints out 0.333333.